I hope everyone got a chance to try this one. It's a nice, easy one. You have to turn the terms around, but that's about the only thing. So for this, we have an X-Intercept, which means make Y 0. So everywhere we see Y, we make it 0. So we have 0 equals, and as I write this, I'm going to put it in the proper order because we learned way back in the first section of this chapter, all polynomials are supposed to be in descending order, which means highest power to lowest power. And now you can see it's a nice, simple little problem. Leading coefficient's 1, so I don't have to do any AC method. I can just go right to my parentheses. All signs are plus. So we have factors of 2 that add to 3, which would be 2 and 1. So x plus 2, x plus 1. Yay! Then if a times b equals 0, either a is 0 or b is 0. So I solve these two equations and I will get my two x-intercepts. So x equals negative 2, x equals negative 1. So y is 0, x is negative 2. X is negative 1, y is 0, so there's my two x-intercepts. So I know this parabola comes up, and I know it goes through the x-axis at those 2 points. And you guys already did this in the prerequisite chapter, so hopefully this is a good review for you. So y-intercept means make x 0. So go up to your equation, and everywhere you see an x, make it 0. 2 plus 3 times 0 plus 0 squared. So 2 plus 0 is 2. So my y-intercept is x is 0, y is 2. Make sure and keep it in the right order. X is first, y is second. Okay, so let's go ahead and look at our word problems. So the function f of x equals 3x squared plus 5x plus 2. That represents the number of households in thousands. Important, you're going to see that in a little bit. In a certain city that have a computer X years after 1990. Another important thing. So if I say how many computers were there in the year 2000, X needs to be 10. Because 1990 is the base year. So it says X years after 1990. Well, 2000 is 10 years after 1990. So X would be 10. So in what year, so that's what they're asking, so they want to know 1995, 2000, 2007, were there 10,000 households with computers? Well, this is what represents households. X is years, this is households. But since households are in thousands, I'm not going to put 10,000 there. I'm only going to put 10 because it says it's in thousands. So I'm going to put the number 10 right where f of x is. Thank you, helicopter, right during my video. So my new equation is going to be 10 equals 3x squared plus 5x plus 2. So everybody understand why I did that? So this means f of x is 10. How do I know that? Well, here it says f of x is the number of households. And here it says in thousands, so I know I have to take those 3 zeros off. So notice the quadratic. So anytime I have a quadratic and I'm asked to solve, I have to set it equal to 0 first. So subtract 10, and you always want to keep your x squared term positive. So I have 3x squared plus 5x minus 8. And I like it turned around. Just seems confusing to me, like I can't work it as well when it's backwards. I don't know what that is. So I see 3 terms, so the only way I know how to solve 3 terms is going straight to the bubbles, which is when the leading coefficient's 1. I don't have leading coefficient 1. The only other way I know how to solve is with AC method. So this would be factors of 24 that subtract a 5. So that would be 8 and 3, right? Signs different. And this one means the largest one has to be plus. So positive 8, negative 3. So now we're going to take out this middle term and replace it with these two values. So 3x squared minus 3x plus 8x minus 8 equals 0. So once we stretch it into 4 terms, then remember we do grouping. So GCF here would be 3x. And when I take a 3 and an x out, I'm just left with 1x. And when I divide 3x by 3x, I get 1. So x minus 1 plus, here there's an 8 common. So I take an 8 out and I get x minus 1. And then remember, x minus 1 is my next GCF. So I take it out as my GCF binomial and I'm left with 3x plus 8 equals 0. So GCF, x minus 1, what's left over? 3x plus 8. Then we use our zero factor property. If a times b equals 0, either a is 0 or b is 0. So solve those two, keeping in mind it's a word problem, so probably one answer is not going to make sense. And remember, x stands for years. So that's one thing you could think about. So x equals 1. This is going to give us a negative number. What do you think about that? Can we have negative years? No, we cannot. So that one's gone. We can't say, oh, negative 8/3 years after 1990. So x is 1. 1 year after 1990 would be 1991. So you could just, to show your work, you could say 1 plus 1990. Because this problem says in what year. So that's how I know to write 1991. So I don't say in 1 year because it says in what year. I would only say in 1 year if it said how many years from now will it be. So in 1 year, 10,000 houses will have a computer. This one we had to throw out because this is years. Years can't be negative. Okay, let's do one more and then we've probably done enough word problems. We already did one like this, so I don't think we need to do another one. So let's go ahead and do number 10. So the population P of T in millions can be approximated by this. So I always highlight that important stuff because you saw how important it was here. What if we would have put 10,000 in there instead of 10? Do you think we could have been able to solve that problem by factoring? It would have been pretty tough. So you have to read that important stuff and underline it. So this is the population. T equals 0 represents 2000. So if I asked you to find the population in 2020, you'd make T 20. If I asked you to find the population in 2053, T would be 53. Okay, so year 2000's T equals 0. So this one is asking for 2006. So that means T is 6. So this is just an easy little plug and chug problem because everywhere I see a T, I'm going to put in 6 and then I'm going to go to the calculator. So population 6 years after 2000 is negative 0.01 times 6 squared minus 0.062 times 6 plus 127.7. So that is my equation. Now I just have to plug it in. So let's just check and make sure everything looks good. So negative 0.01 times 6 squared minus 0.062 times 6. Yep. So now we just plug it into the calculator and it does its magic and gives us the answer. I think I'm going to do it like this. Okay. So we have negative 0.01 times 6, then I'm going to hit my squared key. So looking good, because these you really got to double check because they're so easy to make mistakes. Subtraction 0.062 times 6. So negative 0.062 times 6 plus 127.7. So 126.968. 126.968. So P of 6 equals 126.968. And then we have to learn what the appropriate label is. So we look up and see, what does P represent? Oh, P represents the population in millions. So we don't have 126 people. We have 126 million people in Japan in 2006. And I don't want to make a video just for the last one. So since we already did a geometry problem a couple pages ago, I'm going to forego that one rather than have an extra video. So if anybody wants to do it, send it to me to check. I would be happy to check it. Okay, so that will be the end of chapter 4.